The Open Orbit CubeSat team is developing a satellite with the associated infrastructure. Currently, we have two projects, our ground station and our altitude prototype payload, which allows for rapid iteration of CubeSat subsystems. Additionally, we have a VIP team developing a machine learning imaging payload, which will reach altitudes of up to 100,000 feet.
Our project started in 2025 with a group of mechanical and electrical engineers. In May, we launched our first high-altitude balloon, which didn't go so great.
Oh, and there's the tracker!
But since then, we have worked very hard to develop several iterations of our high-altitude prototype payload and develop a fully functional and operational ground system.
Our team launched the second iteration of our high-altitude payload in October last year. This launch was extremely successful, and we were able to test our sensing and tracking systems that we had developed. We were also able to capture this amazing video footage. My mission on the HAP team has been ensuring the thermal safety of the payload. I've done this by estimating heat transfer in the intense atmospheric conditions, and I've also analyzed data after retrieving the HAP to see how well our system performed and what changes need to be realized.
Our previous system used a Raspberry Pi and several other breakout boards to record atmospheric properties, record video, and transmit its location back to the ground live. Our newest system, though, will be using an STM32, will be much more integrated and power efficient compared to our previous designs.
So as an electrical engineer working on a multidisciplinary team with computer and mechanical engineers, I've decided to focus on power, which to me really means looking at spec sheets for motors, for fans, for any devices requiring power, and making sure that I size power electronics, size wires, and overcurrent protection devices to make sure that power is delivered to all those devices safely and efficiently.
As a mechanical engineer on this team, I oversee the design of the main structure. This includes making sure all the components can be mounted, as well as ensuring that it can survive the loads of launch and landing. I've learned a great deal about managing the requirements of a project like this and making sure that requirements like size and weight are met across various teams.
Here we take advantage of the EMEC using the mills and the lathes to make components, whether that's motor collars for the ground station or external rails for the HAP. This is where the magic happens.
We are responsible for manufacturing, structures, and like wind loading. We need to make sure that the ground station can withstand winds up to 100 miles an hour.
As a computer engineering student, some of the things I've done on this team is work to configure this Raspberry Pi and the operating system on it, which is a Linux-based operating system, to allow it to connect to Wi-Fi automatically and like send data remotely using Python, as well as kind of just creating a network structure that allows that Raspberry Pi to like communicate with our main server and then this computer over here. And then part of that is sending metrics to our main server, which is displaying them all on this monitor over here on our personal dashboard website.
This year for senior design, I've learned how to use a lot of tools to help me with my electrical engineering. I've used digital multimeters and oscilloscopes to measure current waveforms as well as voltage and impedance. I've used DC electronic loads like this one right here to test out power supplies and power electronic equipment. I've also furthered my skills using soldering irons to make PCBs like this beauty right here.
In order to communicate with satellites and our payloads in the future, we use GNU Radio as our visual interface software that allows us to lay out the whole DMOD chain and then also embed Python blocks to decode it.
So here's a little bit of a sneak peek of something you might be able to see on E-Days. What we're hoping to accomplish is to support our HAP team with send and receive on 2 different bands. In addition to that, we're also trying to support our friends over at Alta University by supporting send and receive using our 437 megahertz antenna as well.
And additionally, we're trying to do another full iteration of our high-altitude prototype payload system. That means testing and flight all before E-Days. And keep an eye out at E-Days, April 23rd, we are planning on doing a demonstration of our system by doing a launch the morning of tabling.
We are creating efficient and intelligible documentation to create a smooth path down to future semesters. In addition, we are hoping to ensure Open Orbit's first satellite will reach space.
A year ago, there was no satellite program at CSU, but thanks to our students, both mechanical and electrical engineers, working tirelessly to bring this program together, we've made great strides bringing aerospace initiatives to CSU. In the ECE department, we found a spot that we could home our 13 seniors to be able to work on this for their project. And a special thank you to the ECE faculty, the engineers and residents, and to the senior design course coordinators, all there in Hine, for really helping us push aerospace initiatives forward at CSU. Looking to the next several years, we want this program to sustain and continue, and to really bring ECE to the table when folks think about aerospace here at CSU.